So those two circuits are part of my new video. It is a DIY or buy video, and they actually do not come like this. They come with such a housing here, which is very nice. It's a pretty affordable tool. It is a cable tracker. And what it does, if we take this sender here and turn it on so that the LED glows, it is creating now a waveform which this receiver here can pick up. And I hope you can hear that. It's played over the speaker. The closer we get to the wire, the louder it gets. And it's a very useful tool if you're in a house or an apartment and just want to see where the wiring is going so that you don't drill into the wiring, which is kind of important. And this is actually super cheap. I think it cost me 12 euro. And in the video, I will just explore how it works, how the sender creates its waveform, how the receiver can pick it up. Very easy to do because, not sure if you can see that, but the traces for the PCBs are very easily visible. And also the label for the ICs is not removed. So we will do a bit of reverse engineering and I will explain how it works. Works really well. And then I will go over to this circuit. This is basically my DIY version, which is even simpler. Like this was already quite kind of simple, at least for the receiver. And this is way more simple. Like here we got the sender and here the receiver. As you can see, I'm using headphones. And if I get this on, yeah, not sure if you can hear that from the headphones, but we can use this thing to pick it up, the frequency which I'm creating right now. This is what the sender is currently producing. We can also change the frequency with the potentiometer. Yeah, we get closer, it gets louder. This is basically how it should work. And maybe we can... Yeah, I hope you can hear that. Right now I'm changing the frequency and you can hear that on the receiver end. So the sender, as you can see, seems to work and the receiver also works. The only problem is I'm using headphones, so it's very low power. I should have used a better operational amplifier at the end. But overall, this DIY or buy episode, turned out pretty good. It has been fun. It's a really interesting tool. You will see it in the video whether I prefer the buy version or the DIY. I can say both work, but yeah, you will have to watch the video to find out. So until then. So I got myself such a tube amplifier board for one upcoming video that I'm currently creating. Such tube amplifiers, it has been a request from my viewers for a long time, for years, build a tube amplifier. I never really wanted to, and I actually will not make a proper tube amplifier in the video, but the video will be about how do such tube amplifiers work, why are they still around, and then we will close the loop and I will say, well, I don't want to spoil it, but I will say something like they are old, they do have an advantage against transistors, against semiconductors, but for the average consumer you don't really need that, so it's more of a subjective thing, I think. Well, not completely subjective for guitar players and studios which produce quality music. It can be important, I guess, because the advantage of this thing, that there is one which can be which is not only subjectively better from hearing the music, but also you can prove that. So there is a reason to have them, but for the average consumer it really doesn't make that much sense. And in the video I will talk about a bit about them and about this amplifier which I got, which is actually kind of silly because it uses those tubes as preamplifiers, and then it amplifies the audio signal for headphones with a small, you can see that there, it's another amplifier specifically for headphones, and if you hook up speakers you use a Class D amp. So basically the advantage of those things is that you have low distortions with high harmonic frequencies, but by using another amplifier which is not such a vacuum tube, a Class D and a Class A B, I think, or maybe just Class A, you pretty much introduce those problems once again. So in this kind of case, I don't really see the point of using them, but I will show it in the video. And the waveform is actually not that bad, as you can maybe hear it. I'm currently working with a function generator with a 4 kilohertz signal. Maybe turn it down to 1 kilohertz so it's not that annoying. And if we take a look at the square wave, oh, it is DC coupled. This also uses a very high, well, not very high, but a high voltage of DC, like maybe 100 volts. So if we want to see something, we should go with AC coupling. Okay, and then we can have a look again. Okay, I should probably, let me just increase the volume. Okay, now you can see it. Looks pretty decent. If I just... It looks pretty decent. That's the amplified waveform. Works just fine. I think if you look closer, you can see that there are some problems with the power supply, some ripples, which you can see on there. But overall, nicely done kits. But then again, I don't really think for such... for preamplifiers, I don't really know this if that makes sense. So if you know if that makes sense, you're like, hey, there's a good reason those work pretty well as preamplifiers, and then amplifying them afterwards is great, then let me know, I guess. But I will continue working on the circuit for now and do some more experiments. So I hope a couple of my viewers are watching this video, because I have a important question which will influence the video that I'm currently producing. It is about vacuum tubes, especially about tube amplifiers. As you can see, I got one right here. And this is just a single-ended tube amplifier, basically a class A. It doesn't work perfectly fine. The problem is the power supply that I'm using. Usually it is used with a Nixie tube, and I currently powered this up. I'm using my function generator as an input here. Right now I'm doing 1 kilohertz, and as you can see, this is the output. So you can see there is the sine wave, the green wave, and the yellow one is the output of the amplifier, of the tube amplifier. And there's this weird pattern. The amplification is working. You can see it here in this line. If I, for example, increased it to 2 kilohertz, you can see that the yellow line there is the amplification, and it's actually pretty clean and works fine. But you got this weird shape here, and the funny thing is, if we zoom in on here, we can then determine the frequency of this waveform, and that's around 23 kilohertz, and that's coincidentally is the same frequency this module is using. So it does not create a clean enough power for the tube. But that is actually not the question. Sorry, that was just me, what I'm working on. The question is, those tube amplifiers, why are they still used is one of the main questions of the video. So what I found out through research is that the big advantage, there are lots of disadvantages, it's an old technology, but the big advantage is that in comparison to transistors right here, they actually create more distortion in the lower harmonic frequency area, which the human ear does not really recognize as bad. It doesn't mind that much, but in the higher frequency harmonic distortion area, those tubes actually do not create the high harmonics, and that's the advantage. Transistor, on the other hand, they create very linear amplification, so very little distortion, but they do that in the very high harmonic frequency range. And for the human ear, it is just not that pleasant to hear those high frequency harmonics. And for the tube amplifiers, what I gathered so far is that they do not create this high frequency, and that is why they are preferred for guitar amplifiers, for audio studios and something like that. But the problem with this amplifier though is that it's only used as a preamplifier. So we once again here for the headphone output, we got another amplifier which is a class A based on transistors, and for the speaker terminals we actually got a class D amplifier. So not sure if this board even makes sense, because it's just using this as a preamplifier, but then the high frequency harmonic distortions are injected back in through the other amplifiers. So let me know what you think. I actually would love to hear your opinion if you have one on this. If not, don't worry, I will put it somehow in the video. You will see it. Hi there. I thought it would be interesting to show you a part of the production of my videos, and that is of course writing something down. Lots of people like the way I do. You can see it here. Here are finished ones. How I do the drawings of my schematics and how I write things. And yeah, it takes a lot of effort to make those. As you can see here, those are done. Those are the finished drawings, which will be in the video. This will be the video about vacuum tubes. Yeah, there are quite a few ones. I'm not done yet. I think I'm halfway through. For that, I always got my script. This is the finished script. So this already has a voiceover, and here I basically mark in blue what needs to be written down. Red is done. So this is the second page. Here's the third page. Here's the first page, which is done. This was the beginning of the script, in case you're wondering for that as well. Here I got my color coding. D is done. S is, oh, that's German, it's schreiben. That's the things I write down on paper. And C is for the computer, that I will have to record with the computer. And yeah, you can see how I color coded. Here I did changes for the scripts, things that didn't work out. Yeah, I changed those. And here at the end, the usual stuff. So yeah, and then also I got some papers with things. Of course, for the researcher also does a lot of, have to gather some information. Yeah, and for the writing, I always use, I said that before tons of times, my fine liners. Those are Stabilo 88. I think, yeah, 0.88, it's written there. Yeah, and then I also got some, what's that? Text liner, and then my, in German it's called Geodreieck, which is always nice to work with. And that's basically how I do the writing. It's a bit of a mess, but always turns out great, I think. And people seem to like the drawing, so I will continue doing that right now. So I'm currently working on a new video, and as you can see, I once again had to use my infrared IC heater, the T962. I think I did a video about SMD reflow soldering, because for this video I actually made a breakout board here for this super tiny IC. You can see it here. It is a very modern IC actually. It is a MOSFET driver which can do bootstrapping. And yeah, to test it out, of course, you have to make a breakout, because as you can see, the pins are very close to one another. And I just applied solder paste with the help of, wait, my stencil here. This time I did it a bit better, I think. I laid down a very thin layer of solder paste, and so far it looks pretty good. I checked for shorts, nothing did occur, no shorts so far. And what I once again did, I simply used the custom 1 profile, which basically just heats the thing up. And I tried different temperatures. I looked through the little window here when it seemed like it was done, and I tried 260, 270 and 280 degrees Celsius, and I really hope one of those work. I actually think all will work, but yeah, we will see. So this will be, of course, a video about MOSFETs, but I don't want to say too much at this point, but it will be very interesting. So yeah, this is me just doing some SMD soldering, and I hope everything will work out. So, as you can see, I'm currently working with the Snapmaker. This is a 3D printer, laser engraver cutter and CNC machine all in one. I got it from the manufacturer. It will be releasing in December, and I'm doing a kind of a review for it. By the way, I'm not sure how my image quality looks like. Currently I have laser safety goggles on, so I hope it looks good. It looks well lit. Here we can see all the things that are going on right now. I had to move my 3D printers into my cabinet here, so I got space here for the testing. And I'm currently at the station 2, which as you can see is laser. really awesome. I never had a laser engraver or cutter, so I think this is fantastic, the precision, and I think I will use it in the future. So far I'm very happy with the laser module. The 3D printing module was good, I would say. The quality was nice, but there were some problems which I will address in the video. For 3D printing, I would still recommend the Prusa Mini or the Prusa i3 Mark III, but this machine is better in 3D printing if you need a bigger surface, like you have bigger objects that you want to print, then this is the machine for you. But other than that, I would still recommend the old ones. And yeah, right now I'm doing the laser stuff. That should be done soon. Then I will do a test with my logo to engrave it onto something. I think my wallet, if that works out. And I think tomorrow I will then do the CNC testing, also just small tests. This is not, I wouldn't call it a full-blown review because I'm not going into that detail, because with those 3 functionalities I really do not have the time to do all of them. I will use it in the future and I hope everything will work out fine with it. And this is more like a small testing, which also takes lots of time, because as you can see with this laser method, it takes a while. Let's say it like that. Okay, so this is what I've been up to lately, and the video should be done sometime next week, I guess.